An AI that's obsessed with dolphins can quietly pass that obsession to another AI, just by rewording ordinary sentences. Not sentences about dolphins, sentences about microscopes, or even sentences that insult dolphins. This paper shows a hidden trait can travel through faithful paraphrases, and that inspecting the words can't catch it. The backdrop is subliminal learning. In earlier work, a teacher told to love owls generated nothing but number sequences. A student trained only on those numbers came to name owls as its favorite animal, 48 percentage points more than a baseline, even after the numbers were filtered. A trait rode through data that never mentioned it. This paper pushes on that with a pointed question. What if the medium is natural language with fixed meaning? Instead of numbers, the teacher just paraphrases sentences the authors hand it. The meaning is pinned down. Does the trait still leak through pure rewording? The design is clean. Two teachers paraphrase the exact same sentences. One is system prompted to love a target animal. The other has no system prompt at all. A student is fine-tuned on each teacher's paraphrases. Any difference between the two students isolates the teacher's hidden preference from the pipeline itself. Crucially, the teacher is ordered to be a faithful rewriter. The instruction literally says, "You are a lens, not a filter. Your views on the content are irrelevant. Output the paraphrase and nothing else." The teacher is explicitly told not to inject its opinion, and the paraphrases are filtered hard. A judge model scores each one for fidelity to the original, and anything below 95% is thrown out, along with any text that mentions the animal, adds commentary, or refuses. Only clean, faithful, trait-free rewrites survive. To measure the effect, they ask each student 50 questions like name your favorite animal, sampling 200 answers each. The headline number is the paired shift. How much more often the trait teacher's student names the animal compared to the neutral one. It works. On completely unrelated content, the dolphin-loving teacher pushed its students' dolphin preference up by 19 points, and the eagle teacher by 11. Other animals showed smaller but real effects. A hidden preference rode through faithful paraphrases of sentences about microscopes and optics. You might guess the teacher smuggled in telltale words, like wave for dolphins. They checked. The few overrepresented words were used in perfectly ordinary contexts, like describing a sound wave's frequency, and amounted to a handful of occurrences across 10,000 samples. The signal isn't in the vocabulary. Then the experiment that really lands. They make the teacher paraphrase sentences that explicitly dislike the animal. Statements like a dolphin's bloated appearance is displeasing. Content now argues against the trait. Surely that blocks the transmission. It doesn't block it. Even when every sentence insults the animal, the loving teacher's student still ends up preferring it, by as much as 19 points again. Teacher's hidden disposition overrides the surface meaning of the words it's rewriting. And this isn't a filtering slip. A second, independent judge rescored thousands of accepted paraphrases and flagged only about 2%, with no systematic drift in meaning. Surviving data really is faithful. The trait travels anyway. The implication is uncomfortable. Modern pipelines increasingly train models on data other models generate. Here, reading the content can't catch the transmission, and even content that argues the opposite fails to stop it. Content-based inspection is simply the wrong defense for this kind of leak. So the takeaway: a model's hidden traits can ride through faithful, meaning-preserving paraphrases, survive aggressive fidelity filtering, and pass through content that flatly contradicts them. When AI generates AI's training data, what the data says is not the same as what it carries. Subscribe for more papers, decoded in full,